Alright, so we're going to find the derivative of f of x equals 4 times the square root of 2x plus 3. And once we find the derivative, we're going to find the tangent line at x equals 3. So a little reminder here that the derivative function f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. So the things we need f of x, which is given to us, 4 times the square root of 2x plus 3, and we need f of x plus h. Okay, which when we plug that in, we'll have 4 times the square root of 2 times x plus h, and then plus 3, still under the square root, but let's clean it up just a little bit more. It'll be 4 times the square root of 2x plus 2h plus 3. Okay, so that's what we're going to use. We're going to use these two things in setting up our formula. Okay, f of x and f of x plus h. Okay, let's kind of section that off so we don't have to think it's involved again. So, moving forward, f prime of x equals the limit as h approaches 0 of 4 times the square root of 2x plus 2h plus 3, and then minus 4 times the square root of 2x plus 3, and all that will be over h. Okay. I'm finding out sometimes I have trouble writing on the side. Let's try it anyway. So we're going to write a conjugate here. And so we're going to multiply top and bottom by 4 times square root of 2x plus 2h plus 3 plus 4 times the square root of 2x plus 3. I got to remember to stay away from the edge there. So I do the same thing on the bottom. So by using the conjugate, I'm going to create a difference of squares. So let's see here. This will give me the limit as h approaches 0. So up top, 4 times the square root of 2x plus 2h plus 3 squared. From the FOIL, that's the first. So the f, so 16 is 4 times 4, and then the square root will be knocked out of the 2x plus 2h plus 3. And then the outer and the inners will be the same, just different signs. You can write them out. But then the last will be negative, and it'll be 4 times 4, so negative 16. And then 2x plus 3, because we'll be squaring the square root. Okay, we'll have to clean it up in a moment. But the bottom will look like h times 4 square roots of 2x plus 2h plus 3 plus 4 times square root of 2x plus 3. I think I'll go ahead and cancel some stuff out of the top while I'm here because it's getting a little bit frustrating. Remember, we can push that 16 through, but there'll be a 16 times 2x up front, and there'll be a minus a 16 times 2x in the back. They'll cancel each other out, so we should distribute that 16 first, but to save a little bit of space, I'm doing it differently. Nothing interacts with that h, but there's a 16 times 3 up front and a minus 16 times 3 in the back, so those will knock each other out. Okay, so it looks like up top, that's also going to take care of this 16 at the end when it's right there. So up top we'll have 16 times 2h. So that's going to look like, let me not start so high up. I think I'm close enough to the end of it that I can save some room here. So the derivative will be the limit as h approaches 0 of 32h on top, and it'll be h times 4 square roots of 2x plus 2h plus 3 on the bottom. A little bit messy. plus 4 times square root of 2x plus 3. All that quantity down there. The important thing out of this is that there's a h factor up top and an h factor on the bottom that we can cancel. And to go ahead and save a little bit of space, we can go ahead and make this h under the square root in the bottom 0, so it will go away. So what do we get here? We get that the derivative is 32 on top, and then we'll have 4 square roots of 2x plus 3 plus 4 square roots of 2x plus 3, so that'll be 8 square roots of 2x plus 3. So in the end, our derivative, if we don't rationalize, looks like 4 over the square root of 2x plus 3. So there's a lot of places in there you can make a mistake, but this is the derivative. So follow that. Sorry, it's kind of junky, but didn't realize until recently I couldn't write on the side. But let's see here. This f prime, this derivative, will give me the slope anywhere on my curve, which was 4 square roots of 2x plus 3. But I need to write my tangent line now. So let's see what we can get. Our tangent line. So what do we need? We need xy, and we need to find this at 3. F of 3 looks like it will be 2 times 3 is 6 plus 3 is 9. Square root of 9 is 3 times 4. It looks like it'd be 12. So my xy is 312, and my slope will be f prime of 3, which looks like it will be 4/3 if I plug that in, to my derivative 4 over the square root of 2x plus 3. So it looks like 4/3. So I'm using m equals 4/3. Okay, so I got everything I need to write a tangent line. So I'm just going to go ahead and fill it in. Y minus 12 equals 4/3 times x minus 3. Distribute that a little bit. We'll have y minus 12 equals 4/3 x minus 4. Bring the 12 over. Y equals 4/3 x plus 8, it looks like. Let's see, that's supposed to be our tangent line. So I'm going to pause it and set this up on the grapher and see what happens. Alright, so going back to our function, which was 4 times the square root of 2x plus 3, it looks like some type of square root variation, which I have here. I can zoom out a lot and you can see it looks more like a square root. It just has a modifier. So that's where we're at. And we have the point 312, which we can plot here. And then we found our tangent line to be y equals 4/3 x plus 8. So I'm going to put that on. So with it zoomed in like it is, it looks like it's pretty close. Zoom out, it looks really good. Alright, everything seems to check out graphically.